Alright guys, so last class we talked about transformations just briefly. Today we're going to go slightly more in depth, not much. So last class, if you remember, we talked about absolute value parent function, which was just y equals the absolute value of x. This is the most basic form of an absolute value equation that you can get. This is what it looks like when it's graphed. If you notice, the absolute value of the vertex right here is at 0, 0 at the origin. So any change to this equation, the parent function, is a transformation. Alright, so this is our standard form for absolute value equations. Okay, this is how you'll most often see it, but instead of a, h, and k, you'll have numbers there. Okay, there'll be some numbers. So h and k represent our vertex. Okay, h and k are vertex. That's why with the parent function, when you have y equals the absolute value of x, there's not, you know your vertex is 0, 0, so there's not going to be an h, and there's not going to be a k, right? And then your a value, that number is just a 1. So 1 times the absolute value of x, this is our parent function. Okay? So this is going to represent, or we're going to use this to represent our different transformations. Okay, so first one I want to start with is the k. Okay. K is the value that's added or subtracted outside of your absolute value signs, right? This is what shifts our graph either up or down, right? So if that number is a positive, if that is a plus, right, then we are going to have a vertical shift up. Extra wobbly today. Sorry, guys. Okay. If that number is a negative or it's a minus some number, then we have a vertical shift down. Okay? And then we're going to talk about the same thing with our h. This is why when you plug in a 4 here, you have a minus 4. You would think it goes left, but it really goes right. It's because the h in our vertex is positive, so it changes signs, right? So we're going to come down here. If this were a positive, right, a positive or a plus some number inside the absolute value sign, so x plus some number inside the absolute values, then we are going to have a horizontal shift left. Okay, and then if this is an absolute value of x minus some number, minus in there, then we are going to have a horizontal shift right. Okay, so these are kind of your rules, right, or kind of your shortcuts. So this is important information to know. This a value, we're going to have a couple things about a. Okay, the first thing we'll say is that if it's positive, okay, it opens upwards, just like normal, okay, meaning your absolute value function opens upwards. If the value is negative, it is going to be reflected across the x-axis, or it opens downwards. So it would look like this on your graph. Okay? And then one more thing about our A value, if I don't run out of room. If A is greater than 1, so if this number is any number greater than 1, 1.1, 2, 3, 10, 500, whatever number that is, if it's greater than 1, okay, then we say it is a vertical stretch. I'll explain this more in a minute. And then if A is less than 1, okay, less than 1, but it's got to be greater than 0, okay, because these negatives, this negative means reflected across the x-axis. This number is negative. It doesn't affect whether it's a stretch or I'll write it, or a vertical compression, okay? We'll get more into what these words mean in a minute. But if this number, like I was saying, if this was a negative, we'll say a -3. The negative would make it reflect across the x-axis, meaning it opened downwards. And then we'd ignore the negative and we'd just look at the 3. Since that 3 is greater than 1, it'd be a vertical stretch, okay? We'll get to some examples in a second. All right, the first one we're going to talk about are vertical transformations, where your graph is shifted, or your function is shifted up or it's shifted down, okay? So one example would be y equals absolute value of x plus 4. It's a positive 4, which means we're shifting our parent function, right? We're just taking this parent function, the only transformation and only change to it is that it's being shifted up 4 units, okay? So I would count up 1, 2, 3, 4. I would leave my vertex at 4. And then I would have my function. Same function as my parent function, but it's been shifted up 4. So we've transformed it to have a vertical shift up of 4 units, okay? And then down here, y equals absolute value of x minus 2. So it's just like our parent function, except we're shifting it down 2, okay? So down 2. So exactly the same, only difference is that it's no longer, the vertex is no longer at the origin, the vertex has now been shifted down 2 units. All right, and then for our horizontal transformations, so the number inside of the absolute value signs that's either added or subtracted to your x, inside of your absolute value signs, those are going to be our horizontal transformations, which are going to shift us either left or shift us right, okay? So it's opposite of what you would think. So since this is x minus 3, okay, if you remember minus inside the absolute value signs, that actually shifts us right. Okay, so we're going right 3 units. We're just taking this parent function and we're shifting it to the right 3. That's it. So our vertex is now at 3 on my x-axis. And then we would have our function. Okay, same with this function down here, y equals the absolute value of x plus 1. We're going to shift it horizontally to the left 1 unit. And that's where we put our vertex. And there is our parent, or there's our function, okay? Shifted left 1 unit from our parent function. All right, so here we have y equals negative times the absolute value of x. The negative's on the outside of our absolute value signs. all that negative is going to do is it's going to make our parent function reflect across, this is our x-axis, right? So it's going to reflect or flip across that x-axis, right? If you were to reflect it to the other side, your origin doesn't change, right? Our origin stays the same at 0, 0, but then it reflects across and it now opens downwards. Okay, that's it for reflected across the x-axis. We'll get back to these examples in a second.